Hi students, this is Mathematics for grade 12. I am Hafta. Today we will see some pointers on the first chapter, that is Unit 1, Sequence and Series. At the end of this class, you are expected to define what a sequence is, find terms of a given sequence, and explain the difference between geometric sequence and arithmetic sequence. Very good. Let's see first what a sequence is. Sequence in mathematics is a function where its domain is the set of positive integers. A sequence, most of the time, we denote a sequence like this, is a function. It's a function where its domain is the set of positive integers. Most of the time, they start with 1. Sometimes we may start with some positive integers other than 1. So, in a given sequence, this up to A and R said to be terms of a sequence. Terms of a sequence. And this is, A1 is sometimes, most of the time, called the first term of the sequence, and AN is said to be the general term or the nth term of the given sequence. Notation. A sequence may be denoted in different types. Let's say, for example, for this sequence, A1, A2, up to AN can be denoted by either this one or n starts from 1 up to infinity. They denote the same concept, that is a sequence with this structure. So you can put this in brass, or you can use free of brass. So sequences can be described in many different ways. Let me show you 4 of these ways. The first one is, we can describe a sequence by listing the terms of the given sequence. For example, the sequence of natural numbers, okay? The sequence of natural numbers can be described by listing. We may list all of the terms of the given sequence, or we may also list the terms partial. So we can only list the sequence of natural numbers partially because it is an infinite sequence. So 1, 2, 3, blah blah, up to this. We can describe a sequence by listing the terms. And the other one is by writing the general term. Writing the general term. But for example, an is given by 2i of n plus 3 over 5. We can describe a sequence like this. This is said to be the expressing a sequence with a general term. The general term is an. The third one, by drawing graphs, okay? Drawing graphs. You can plot a graph that describes the given sequence by plotting the points of the relation in a given plane. The fourth one is by recurrence relation. Recurrence relation. We will define this well in our next session. Recurrence relation is a general formula that relates a general term to one or more terms that come before the general term. We will see, and we will have some examples for this. Okay. Sequences can be categorized into two groups based on the number of terms that they contain. That is, the first one is the finite sequence, and the second one is the infinite sequence. When we say a sequence is finite, that sequence has a last term. Okay? If a given sequence has last term, we call that sequence is a finite sequence. Let's say, for example, if you have this sequence an is equal to 1, 2, 3, and then 4, up to this. We have a last term 4. So this sequence is said to be finite. And the domain of this sequence is, this one. 1, 2, 3, up to 4. This is the domain. And a sequence is said to be infinite if that sequence has no last element or no last term. Let's say, for example, we can see this, the set or the sequence of natural numbers is an infinite sequence because we can't find the last term of this sequence. It continues without bound. Therefore, this sequence is said to be an infinite sequence. Okay, as I have told you earlier, we will see some points about recursion formula. This recursion formula is a formula that relates the general term of a given sequence to one or more terms of the sequence that came before this general term. Let's say, for example, if a sequence an is defined by this one, a1 is equal to 2 and an is an minus 1 over n for n is greater than or equal to 2. This is a recursion formula. This is a recursion formula. You can use this formula to find the next terms, and you will use the term before this general term. That is, to find an, you will use the an1 term of this sequence. Okay? Let's say, for example, please, students, can you find the first 4 terms of this sequence? Very good. Let's see the problem together. We have the first term of the sequence, that's A1. A1, as you can see, is what? 2. And AN is AN minus 1 over n for all n greater than or equal to 2. So, what do you think is the second term? Okay, A2 is A2 minus 1. Term means it is A1 over what? Over 2, because our n is 2. And what does this show us or tells us? A2 is already, we know A1. How much is it? It's 2 over 2. A2 is 1. Very good. What about A3? A3 is also A2 over 3, because our n is 3. Then A3 is, we have A2 is how much? 1. Therefore, 1 over 3 is the third term of this sequence. What about A4? A4 is also A3 over 4. That is, A4 is equal to, you have A3 is 1 over 3 over how much? 4. You can simplify this expression by multiplying 1 over 3 by the reciprocal of 4, that is 1 over 4. It is simply 1 over 3 times 1 over 4, which is equal to 1 over 12. Okay? Very good. So, therefore, the first 4 terms of this sequence are 2, 1, 1 over 3 for A3, and 1 over 12 for A4. Very good. Let's also see a very interesting sequence of numbers. That is the Fibonacci sequence. This sequence is a very special sequence, and its name is given to the honor of the very famous and Italian mathematician Leonardo Fibonacci. This sequence is what? F1 is equal to 1, F2 is equal to 1, and Fn is equal to Fn minus 1 plus Fn minus 2. That is for n greater than or equal to 3. Okay? This sequence is described using a recursive formula or recurrence formula which is described in this term. Okay? The first term is always 1. The second one is also 1. And the terms next to the second, starting from the third, are given in this form. Fn is equal to, or the nth term of this sequence is the sum of the two preceding terms of the sequence. Okay? Therefore, what do you think is the sum terms of the sequence? What do you think is the third? Because we know the first and the second. Yeah, the first and the second are the same, 1, 1. What about the third one? The third one is the sum of this. That is 1 plus 1 is 2. What about the next one? 1 plus 2, 3. What about the next? The sum of the two preceding terms. 2 plus 3, 5. What about the next? 3 plus 5 is 8. The next one is 5 plus 8, that is 13. You can continue determining the next terms. Okay? Okay, this sequence has a very special application in the determining the number of populations in rabbit production. Okay, in rabbit production. And we can categorize sequences into two very broad categories, saying arithmetic and geometric sequence. Sequences can be categorized as arithmetic and geometric sequences. Now we will see what is the difference between these two, and we will define them mathematically. Okay, let's see first what an arithmetic sequence is. An arithmetic sequence. A sequence in which the difference of two consecutive terms is the same or equal is said to be an arithmetic sequence. That is, if the difference between two consecutive terms of that sequence is constant or the same, that sequence is said to be arithmetic, and we call this constant is common difference. The common difference. Okay? So we will use or apply this definition to find terms of a given sequence. Okay. A sequence AN is arithmetic arithmetic sequence if and only if this relation holds. If and only if this relation holds. That is, an is equal to an minus 1 plus the common difference d. This is said to be an arithmetic sequence. An arithmetic sequence. So, what do you mean by this general formula? Okay. What do you think is A2? A2 is A1 plus D. Where? What's D? D is simply A2 minus A1. Okay? D is the difference between the two consecutive terms of the sequence. And A3 is what? A2 plus D. The same is true for A4. A4 is also A3 plus D, and so on. Okay, we have a very interesting formula, theorem here. Let me write down the theorem, and we will use that formula to determine some terms in a given arithmetic sequence. So, if the theorem states if this sequence is an arithmetic sequence whose first term is A1 and with common difference D, then the nth term of this sequence is given by A1 plus n minus 1 times the common difference D. You can derive this general formula from this. Okay, you can put here A1 plus D instead of A2, and you can put A2 plus D instead of A, and then substitute A1 plus D instead of A2, and then you can arrive at this general formula. Very fantastic. I think you are very clear with this. So let's have an example. Let's have an interesting example on this. Let's have an arithmetic sequence with the third term 12 and the ninth term 14. Then you are asked to find the first term and the 30th term of this sequence. I will show you how to find the first term, and you will solve for the A30th term of this sequence. As you know, it's already given that A3 is 12 and A9 is 14. So, using this formula, AN is equal to A1 plus n minus 1 times D, the common difference D. A3 is equal to A1 plus 3 minus 1 times D. We don't know what A1 is and what is the common difference. They are unknowns. And A9 is given by A1 plus 9 minus 1 times D. and you have this system of linear equations in two variables, okay? The first variable is A1 and the second variable is D. Then, to solve this system, please multiply the first row of the system by -1 and take the sum. Totally, this will be changed into minus A1, and this will be changed into minus 2D, and this will be minus 12, and if you take the sum, this will be 0. Minus A1 plus A1 is 0, and minus 2D plus 8D is how much? Very good, 6D, which is equal to what? Minus 12 plus 14 is how much? That is simply 2. Then divide both sides of the equation by 6, and you will have this. D is equal to 2 over 6, which is equal to 1/3 will be the value of D. This is the common difference. Yeah, it's very simple to find what A3 is. You have a minute to find A3. Very good. Have you tried this? We will see the solution. A1 is, okay, you can use either this one or this one. You know A3 is equal to A1 plus 2 times D from the first row. We know how much is D. Yeah, it is simply 1/3, and what will be 2 times 1/3? It is 2/3. Then A1 is equal to A3 minus 2/3. We know it's already given that A3 is 12. Then 12 minus 2/3 is, okay, if you compute this difference, you will have 36 minus 2. Then A1 is what? 34, 36 minus 2. Yeah, 36 is 3 times 12, that's 36, minus this 2. 34/3 is the first term. It's so simple to compute any term of the sequence if the common difference is known and the first term is known. So, what's A30? A30 is A1 plus 30 minus 1 times D. We know what is A1? 34/3 plus, what about this? 29 times 1/3, because our D is 1/3. Then this is 34 plus 29/3, because we have a common denominator 3. Then this is 63/3, that is 21. I hope you got the correct answer of this question. Very good. Take this question as an exercise. The question is, given an arithmetic sequence with 4th term 8 and 8th term 10, then you are asked to find the first term A1 and the common difference D. Fantastic. This is all about our today's class related to the introductory concepts of a sequence and an arithmetic sequence. By next time, we will see what a geometric sequence is. Until then, goodbye.
Chemistry